Assalamu alaikum everyone. Welcome to the Eduverse, a universe of learning. I hope you all are doing so well. Today we are going to start about a very important concept of physics that is correlated with our previous lecture, that is the vector quantities. Today we are going to discuss about the addition and resolution of vectors, like how we will add vectors and how we will resolve the vector. Understanding how vectors combine and break into components, as I have told you that we will discussing about, and we will understand like how the two or more vector will be combined together and will break into different components. So let's dive about it. First of all, we should to know that what is vector addition. Vector addition is the process of combining two or more vectors to find a single resultant vector. It takes into account both the magnitude and direction of each vector. As we know that the each vector each vector has magnitude and also direction. So, and a vector addition means that considering about their magnitude and direction, adding them both, adding all of the vectors, and then find the resultant vectors, that is actually called as vector addition, performed using geometric or analytical methods. The result is called as the resultant vector. Yes, I have told you that the resultant you will get about, that will be the resultant vector. Follow the rules of algebra. So we will perform all about it in the coming slides. Here we have the example. We have the vector A, it has magnitude, direction in this direction. We have vector B, I think in the same magnitude, but in the different direction. How we will add them up? We will add them up by the head to tail rule, that we will also discuss in the coming lecture. But for now, I want to give you the simple way about it, like to add the tail of the second vector with the head of the first previous vector. So in this way, they both will be connected and both will be added with one another. The tail from the tail of the first vector to the head of the last vector, that will be the resultant, and that resultant is actually equal to the A vector plus B vector. So in this, how we will add the different vectors, and we will understand, and we will study the different ways to make them in contact and to make this addition. Graphical, we have graphical method, head to tail rule. The first one, we have the head to tail rule. In this method, vectors are arranged one after another, aligning the tail of each vector to the head of the previous one, as we have seen in the previous slide, in the previous example of the addition of vector. That is actually like we have one vector, the first one vector, then the tail of the second vector. For the addition, the tail of the second vector add with the align with the or add with the head of the previous vector. In this, how we will add them up, how much we have, that much we will add them up in this way, and resultant we will get by the by attaching the or by lining up from the tail of the first vector to the head of the last vector we have. So this line or this vector direction magnitude will be the resultant vector we have. Draw each vector to the scale. Resultant vector goes from the start of the first and to the end of the last, as I have told you right now, from the tail of the first vector to the head of the last vector, useful for the visualizing direction. Yes, this method is so useful for the visualizing the directions of the all the vector and also about the magnitudes. Here we have the example. Like first we have the vector A having magnitude, and then we will add the second one, like the second one, in the way the tail of the second one add with the or attach with the head of the first one. So in this, how we will add the B vector. This is the direction actually. This one is in this direction. This one is in this direction. Sorry. And we have the C vector that is larger in magnitude but different in the and also different in the direction. So in this how we will add them up as much we have the vector. But the resultant how we will find about that? The tail of the first vector to the head of the last vector. That will be the resultant. Like in this in the same way we have the simple example over here as well. For example, we started from here. First vector we have this in this direction, then we will add the second vector that is in this direction, like the tail of the second vector added with the a line are added with the on the head of the second vector, the first vector. In this way we do the same, follow the same method. In this way all these is ended over here. Now about the resultant. The resultant is from the tail of the first vector to the head of the last vector. That will be the dotted line. You can see this is the resultant vector actually we have of the addition of vectors. So this one was the very simple and very beautifully managed method of the addition of vector, and really it is so visualizing, like it is easily understandable. Parallelogram method. This is the another method also using for finding about the resultant vector. This method is used to add the two vectors originating from the same point by performing by forming a parallelogram. This method is actually for the two vectors. If we have two vectors, but that vector is actually from the same point, now we will how we will find about the resultant vector. We will use the parallelogram method. Draw both vectors from the common point. Complete a parallelogram using the two vectors as the adjacent sides. The diagonal represents the resultant. We will have this example. We will have about the example about it. So here we can see. For example, it's in the Newton, so it's a force vector. Like we have something body is a body in this direction. For example, we have a body in this at this point. We apply a force, as a force is a vector quantity. We apply a force in this direction, in this and this magnitude. This is the magnitude of the force, like in Newton. So 6 Newton in this direction, and from the same point, on the same body, we have the second force that is in this direction, but having the 8 Newton magnitude. So this is the parallelogram method. How we will find about the resultant, as we are not doing head to tail rows, but we have to find the resultant vector. So how we will find about it? We will also draw a same magnitude vector and a same direction on this head, like in this way, and these two are the adjacent sides of the diagonal, sorry, the parallelogram, and also same in this much magnitude from this head to this point. And the dotted lines are actually the same as for the two sides, so it becomes a parallelogram, not a rectangle but a parallelogram. Now the diagonal we have actually like this from the to the facing corners of the diagonals of the square or the box we have over here. So the diagonal actually will tell us about the resultant. The resultant of these two vectors in different direction having different magnitude will be in this direction. This is actually the resultant of these two vectors. So this one method is also very useful, because as we have taken the example of the body having the two forces applied on it, so it is so useful. The parallelogram method is so useful over there to finding about the direction or the resultant direction or the resultant vector of the both the forces. So this one is also plays a very vital role in the physics scenarios and physics problem solving about the problems. Triangle method of addition. This one is a very simple method. For example, if we have two vectors, vector A, vector B, the same as we have done before. This is the variation of the head to tail rule method, specially used for two vectors. This is actually for two vectors. Mean that if we have only two vectors, then we will use the triangle method of addition. For example, if we have, I don't think so we have an example about it, we have to draw it. Oh, yes. For example, if we have vector A in this direction, this is vector A. Okay. For example, this is a vector A we have over here is a vector A. From the head of the A, from the head of the A, as we have done in the head to tail rule, there is another vector, that is B vector. Okay, that is B vector. But this over here, it must be two vectors for the triangle, because it will give us the shape of the triangle. Either it is in this direction, either it is in this direction, not but totally the parallel, because that will not giving us the resultant vector. They will both of them will be added. There must be an angle less than 180 among them, just to having the resultant vector. So now about the resultant vector. The resultant vector, as I have told you, that will be from the tail of the first vector to the head of the last vector. Here we have that is actually the second vector. So this one vector will be the resultant vector. And why this method is also called as the triangle method? Because it always will be among two vectors, will be among or will be applied on the two vectors we have, or finding about the result of the two vectors. This one method will be used for that. And also, if we are using two vectors A, B, it will also give us the triangle at the end. If two vectors, the resultant, this one will always be ended up with the triangle. So that's why it is called as the triangle method of addition. Resultant is from the tail of the A to the head of the B. So this is about the triangle method of addition. That is very useful as well. And now about the second part of this lecture, that is the vector resolution. As the vectors are added, the vectors are resolved as well. Vector resolution is the process of breaking a single vector into two perpendicular components using along the x and y axis. As a single vector is as a vector is added, in the same way, the single vector can be divided into two, or can be break into two different components, or we can say different vectors that is perpendicular to one another, usually along the x-axis and y-axis. That is actually the vector resolution. Opposite of the vector addition. Yes, because in the vector addition we do add the vectors, but in vector resolution we resolve the same vector into many pieces, into many components. Makes complex problems easier to solve. Yes, if we have some problems of the physics, that the force, motion of the body, or such type of something, we can easily finding about the resultant, or finding about the resolution of the vector, and also finding about the direction of the motion. Components are based on the sine and cosine function. Yes, we will discuss about it in the upcoming slide. Resolving a vector. How to resolve a vector? This is the way how to resolve a vector. Given a vector A making an angle theta with the horizontal, okay, horizontal component AX will be A dot cos theta, vertical component will be A sin theta. These components form a right triangle with an original vector. For example, I think we have an example. Yes, over here we have an example. We have, as I have told you in this over there, given a vector A making an angle theta. Okay, for example, we have this equation, this vector. For example, its name is A. Just take from the previous slide. This name is A. Okay, This is the a vector we have. Okay, this is the a vector having an angle theta with the horizontal line. Now how to resolve this? The horizontal component will be r cos theta, like we have a cos theta. Sorry, it's the a cos theta, because we are taking the we are taking the vector as r, sorry, the vector a. So it's the a cos theta will be the horizontal component, and a sin theta will be the vertical component of that vector. So this is actually about the resolving about the single vector is resolved into two pieces, the vertical piece and the horizontal piece. The horizontal piece is actually will be represented like the a cos theta, and the vertical component will be a sin theta. Here we have the r because the vector is called as r or in this example. This was about the resolution of vector. Let's have a simple recap about this again. For example, we have a single a vector having some angle with the horizontal line. Okay, sorry, it's a horizontal line, but I am little bit having mess about it. Okay, now in this one will be the the vertical component a sin theta, and this one on the horizontal line will be the a cos theta, as we have in this example. This is the vector a. This will be the horizontal component of the vector, that is written as the a cos theta, and this one will be the vertical component of the vector, and that will be called as the a sin theta. Summary of the lecture. This was about the today's lecture. Summary of the lecture will be, sorry, okay. Summary of the lecture: vector can be added using graphical and analytical methods. Yes, vector can be added, and by the graphical methods and the analytical methods. Resultant vectors represent combined effect. Okay, as we have taken the example of the force, as I have given you the example of the two forces applied on a single body, that will give us this method. By using this method will give us the resultant effect of the resultant combined effect of vector of the forces. Resolution breaks a vector into useful components. Yes, we have seen into useful components. We will know about the different mainly different components of the vector by resolving it into its horizontal component and the vertical component. So that will be the so useful for us for solving the different problems, for solving the different situation, or having the method, or having the motion of the motion or the direction of the body. So we will easily find about that by using this method. Both are essential for solving the physical problems. Yes, this is what I have told you right now. This is very essential for solving the physical problem. Thank you for watching. This was for today. If it is helpful for you, then don't forget to like it, and also don't forget to share with your friends, because that should also be helpful from you. And the main thing, don't forget to subscribe this channel, because this channel will always be here for you to solve your problems, physical problems, and all the different subjects. I'm also uploading on my channel. And if there's any query, comment box and my email will be always open for you. You will always be responded, inshallah. And yes, we will grow up and cheer up for one another. Okay, thank you so much for today, and thank you so much. Stay blessed, and always try to be happy, and also the main thing, uh, always try to be the reason of smile for others, because that will be so much helpful for you. And thank you so much. Allah Hafiz. Allah Hafiz.